So let's say our URL shortener is working now. We can create links, redirect users, run a few simple SQL queries. Nice. Then product asks a very normal thing. Show me all links for this user with the owner's email and how many clicks each link got. And we do the most common thing. One big table which contains short code, long URL, user email, click count, created at, country, device, everything. For 5 rows, it looks clean. But now the user changes their email. That email is copied in 50 link rows. Now we update 49 correctly but miss one. Now the database is not just storing data, it is storing a lie. So table design is not academic. It is not just drawing boxes for fun. The question is, where should each fact live so the app does not slowly become wrong? At high level, do not start by asking, what table should I create? That sounds correct, but it is little early. Start with the questions the app needs to answer. For our URL shortener, there are four basic ones. When someone opens slash abc123, what long URL should we send them to? When a user opens the dashboard, which links belong to that user? When someone clicks a link, how do we record that event? And later, how do we count clicks by link, country, or device? These questions are called access patterns, which is fancy name. Simple idea. How will the app access this data? If we skip this step, we usually design tables from vibes. Maybe users table, maybe links table, maybe analytics table. It can still work, but we are guessing. So the first move is list the questions. Tables come after that. Now we can look for the real things in the systems. Usually these are nouns, but not every noun deserves a table. We have user that feels like a table because users have identity. They can create links, update profile data, maybe log in later or log out. We have a short link, also a table. Each short link has its own identity, its code, long URL, owner, creation time, expiry time. We have a click. This part is interesting. A click is not just a number, it is an event that happened at a time. For a link, maybe from a country, maybe from a device. So, click should probably be a table as well, which is click events. But country, device, for this version, those are just facts about a click. They can be columns, not tables. That is the small judgment here. A table is usually a thing with identity and a life cycle. A column is usually a fact about that thing. Now we connect the boxes. One user can create many short links, but one short link belongs to one user. So that is a one to many relationship. One short link can have many click events, but one click event belongs to one short link. Again, one to many. Many to many is the other common shape. Let's say a short link can have many tags and one tag can belong to many links. Then we usually create a small table in the middle like link tags. This word, cardinality, only means how many rows on this side connect to how many rows on that side. One to one to many to many, that is all. In tables, we usually represent this with IDs. Users have ID. That ID is a row's stable identity. In SQL, we usually call it a primary key. Short links has user ID. Click events has short link ID. So, a foreign key is not just a SQL feature. It is a relationship written down. We will enforce primary keys and foreign keys properly in the next video, but for design, the idea is simple. The child row points back to the parent row. That is the important part. Let's compare this with the one big table design. In the big table, user email repeats for every link. So, one fact has many homes. That is where lies comes from. Then, clicks start coming in. Where do we put them? We can keep a click count, but then we lose the actual click history. We can store click as a JSON array inside the link row, but now one row keeps growing forever and asking clicks by country becomes awkward. We can create columns like click 1, click 2, and so on, and honestly, this is just bad. That design is already shouting at us. The issue is not one big table can never work. Sometimes denormalizing is useful. We will talk about that later. The issue is not doing it by accident. If a fact has many homes, updates become dangerous. If a row secretly contains many things, queries become painful. Schema design is mostly catching these two problems early. So, our first schema can be very small. User table, ID, email created at. Short links table, ID, user ID, shortcode, long URL created at, expires at. Click events table, ID, short link ID, clicked at, country, device. Now test it again the questions. Redirect by code. Look in short links table where shortcode equals ABC123. Show our users links. Find rows in short links where user ID matches that user. Record the click. Insert one row into click events. Show click analytics. Count click events grouped by link, country, or device. See what happened. We did not create tables because of a diagram told to us. We created tables because every product question now has an obvious place to go. That is what a good first schema feels like. Not perfect but explainable. This is where ER diagrams comes in. ER means entity relationship. Entity is the thing, user, short link, click event. Now, relationship is the connection. User creates links. Link has clicks. That is it. I think the mistake is teaching ER diagrams like a separate subject. Like learn the notation upfront, then maybe someday tables will appear. But in real work, the diagram is just a sketch. It should help you answer what tables exist, what tables matter, what columns matter, and how rows points to each other. If the diagram doesn't help you write the schema or reason about queries, it is decoration only. Keep it useful. So the mental model is simple. Start with access patterns. What questions does the app need to answer? Then find the things with identity. Those probably become tables. Put facts about these things as columns. Write relationships using IDs. And keep asking one question. Does this fact have exactly one home? Because when one fact has many homes, updates become lies. That is the whole point of this video. In the next video, we take this schema and adds the guardrails like primary keys, foreign keys, unique rules, not null, checks and all that. Because designing tables is step 1. Making sure bad data can't enter quietly. That is step 2.